All right, so first problem we're looking at here is we're rounding this number to the first decimal place. When we do that, of course, remember what we're talking about by first decimal. By first decimal, we mean that we're looking at that first number that is after the decimal. So that means in this case that I'm looking at where that 3 is. So when we round to, I need to look at just the one next number, because basically I'm going to be cutting it off there. And the rest of those numbers don't matter, they don't change anything, but that 1, which in this case is the 7, that one does matter. So, does the 7 tell us to leave the 3 alone, or to make it into a 4? Yeah, it's going to become the 4 there. Because this number here is 5 or more. Anytime that number is 5 or more, it tells us to round this number up. If it is between 0 and 4, it means leave it alone. So our final answer, you should be getting 900.4. All right, next up we're going to be seeing how we round this one. So please write down this problem and round it to 3 decimal places. So first up, to decide where that third decimal place is. In this case, that's where that 0 is. Because remember, I'm counting out to be the third number after the decimal place. So I'm rounding to that one right there. So that as I do that then, I'm cutting off this 347. That 347 is going to be gone. But it does tell me something about what's left. I don't care about the 4 and the 7. I only care about the one next digit, and that's the 3. Since it's a 3, do I leave it as 0, or do I round it up to be a 1? Yeah, we leave it alone. The 3 tells me not to change it, and so it stays as 0. But then the question is, what do I have to write for the answer? Because technically then we got an answer of 56.510. Do I have to write the 0 is usually the question that comes up. And it's kind of a yes and a no answer. It depends on what your goal is by writing this out. I need to explain that. So, could I also write 56.51? Those two numbers are technically the exact same value. They mean the same number, whether you include the 0 or not. So why would you include the 0? Including the 0 here tells whoever is looking at this number that this is accurate out to 3 decimal places. If they look at 56.51, they're going to think this is accurate out to 2 decimal places. By writing the 0, you're saying it is actually accurate out all the way this far. It gives the person who's looking at the number a little bit more information. So that's why you would write it in there. Do you strictly have to? No. But oftentimes I will write that in there to show a level of accuracy, how accurate I'm being in it. And people end up asking, wait, do I have to write the 0? No, but just know why we would or wouldn't make that choice. So just a little bit of information there. Above your first graphing grid, I'd like you to please write this equation. Y equals the absolute value of x. Our goal here today with our graphing portion is going to be taking it from just the general shapes that we were seeing yesterday to seeing the exact points that are involved today. So we're going to be graphing this basically point by point and then using that to draw on the curve. Now, based on that work that we did do yesterday, when we have y equals the absolute value of x, what is the shape of that graph going to be? Yep, that's the V shape. So we already know we're going to be looking at something like that. Now that I know the general shape, I now need to actually start plotting some points. Now you notice that this one has not been moved at all. This is actually the same as the parent function. Remember that vocabulary from yesterday? And if you take a look at your notes, it's in fact the very first graph you see on your notes as well. So the big question is, and this is the one that I always want to know, is where does my graph start? We call that point the vertex. So where's the vertex of this graph? Yeah, exactly. It's on the origin, or 0, 0. It means the same thing. So my very first point, I'm going to put a nice clear point there at 0, 0. Plot that point. Make it a nice big point because we're going to be drawing the lines and the curves in later. And I want you to still be able to see the points past that, especially for this first one. All right, now we know it's a V shape from there. But of course, A V-shape could be lots of different things depending on what kind of slope we're looking at on each side. So we do need to be precise about this, because if you just go, it's kind of like that, no, that's not going to work for us. We have to actually be very precise about this. So how do we know what it is? We're going to actually go over 1 and up 1. Because the absolute value of 1 is 1, and this is an absolute value graph. And so what if I go over 2 from my first point? How far up would I go? 2, yeah, because the absolute value of 2 is 2. Okay, so I can plot a point there at 2, 2. And as you might expect, this pattern is going to keep going. We would go over 3 and up 3, 4, 4, 5, 5, and all the way. Go ahead and plot each of those points. Yes, this time we're going to plot every single one of those little things. Now, that's what was going on as I went to the right. We still got to consider what's going on as we go to the left of my starting point. Well, remember I figured out that first point by saying, okay, the absolute value of 1 is 1, so that told me the coordinates of my point. I can do the same thing with negative 1. Now, what is the absolute value of negative 1? 1. Because absolute value makes whatever you put into it positive. And so as I go to the left, I'll go left 1, but I'll still go up 1. Because even if I put a negative into it, I get a positive out. And then if I plugged in negative 2, I'd get a positive 2. And you notice it's just going to keep doing the exact same thing. Basically, the left side is the same as the right side. We're going over 1 and up 1 all the way along. So plot each of those points. And then once you've done that, we're going to draw on the curve. Now, curve in math is a very generic term. Curve can sometimes mean something that actually looks very curvy, and it can also mean something that is a line. It just means the graph, basically. So you're going to draw on the curve, but since this one is a straight V on both sides, you're going to want to use a straight edge for that. When you then go and connect the dots, this is what the resulting curve should look like. It is straight on the left side and it is straight on the right side. Make sure you're actually taking the time to draw it in carefully. Part of what graphing is doing is it's teaching us to be precise. And so if it's supposed to be straight, you're going to make sure that it looks really straight. Now, this graph that we just made, that is our parent function. And if you can graph the parent function, you can graph all of the other different variations of it. And that's what we're going to be seeing next. So above your second graphing grid, please write this equation. Y equals the absolute value of x minus 2. You always want to write the equation with the graph you do. That way, this is an additional reference you can look back at as you do future problems that are similar. All right, so first thing is knowing the shape of the graph. Based on the equation that you see there, what shape will this graph be? It's a V again, yeah. Because this has the absolute value bars in it. Because of these things sitting here in our problem, because of those vertical lines, that tells me it's absolute value, and every absolute value graph will be a V shape. However, this one is not starting at 0. And that's the thing we need to know, is where it is starting. So we got this minus 2 that is inside with the x. And that phrasing that I'm using there is very particularly chosen. The minus 2 is inside with the x. By inside, I'm talking about it's inside of those absolute value bars. And it's with the x. I make a big point of that because if it's with the x, that means it moves it in the x direction. Now the big question is, and the one that trips us up usually at first when we're doing these, is minus 2, does it move it left or right? And if you take a look at our examples, you will see, yes, it moves it to the right 2. Kind of counterintuitive. Every time it's left and right, it does that. So this is actually going to move it right 2. That's my first point. Right 2. Once you know where that first point goes, the rest of the graph does the exact same pattern that we just did in our parent function. That's the beauty of knowing the parent function, because it's just move it and then do the same thing. So if I go over 1, how far up should I go? 1. If I go over 2, how far up should I go? Yeah, over 1, up 1, over 2, up 2, over 3, up 3. And it's that V shape, so it does the same thing on both sides. Plot the points. Now, there's a ton of points you could end up plotting here, so as you get really good at these absolute value graphs, if you want to plot a few of them, that's going to be enough. However, the points that I want to make sure that you do plot included in that, the absolutely necessary points to plot for this, are first, the vertex, our starting point. You always have to plot that. And then, I want you to follow your over 1, up 1 pattern out as far as it will possibly go, and put in the points that are the farthest away from your vertex. Because when you're using the ruler to draw on this line, you're going to be a lot more accurate if the 2 points are further away from each other. If they're right next to each other, it's hard to be accurate, and we end up with a graph that instead is like, well, it was close to that, but we don't want close, we want it to actually be accurate. When you draw in that curve, this is what you should be looking at. Make sure that is in fact what you have on your paper right now. And then once you've done that, we're going to go on to another example. Above your next graphing grid, please write this equation then. Y equals the absolute value of x plus 3. First thing we do is we ask ourselves, what will the shape be? What will the shape of this graph be? It's a V. Because it's still absolute value. Every time you see that absolute value, you know it's a V shape. All right, then the question is, what does the 3 do? Is the 3 inside with the x? No, it's not. Because inside with the x is this part here. It's where the bars are. It's outside of the bars. And since it's outside, that tells us that it's going either up or down. Now, when we went left and right, it was backwards from the way we probably thought it should be. When we go up and down, it happens intuitively. Plus 3 is up 3. So your very first point here is up 3. Plot that point nice and clear. Once you plotted that, plot more. Plot enough to make this graph accurately. And remember what I mean by that. You can plot all of them if you want to, or if you don't want to plot all of them, at least plot the vertex and the point that is furthest away from your vertex. So bare minimum, I would expect to be able to see those 3 points neatly and clearly plotted to be accurate when drawing your actual curve. It should look like that. Check that and make sure it's looking good. Next up is the last absolute value that we're going to do together today. So we're putting the pieces together on this one. You write down the equation above your next graphing grid, of course, as always. And then we start asking ourselves the necessary questions. Like, first of all, what's the shape of our graph going to be? It's a V. Yeah, because it's still absolute value. So we know it's a V-shaped graph. I need to know where to start my graph. That means I got to know what the 4 and the 1 do. All right, so the 4. First of all, notice where the 4 is. The 4 is inside with the x. So that tells me it's going left or right. So then the question is, plus 4. Would that go left or would that go right? And this does go left. Yes, this is going to go left 4. Plus will always go left. Minus will always go right. So I'm going to go left 4, but I don't want to put that point in yet, because I also got to deal with this minus 1. It's going to change where that point goes. Which way does the minus 1 move it? Down, yeah. Because it's hanging on the end, so that tells me up or down. And then there, minus will always go down. So it's going to go down 1. Now we can go ahead and plot our first point. Now you go left 4, down 1, plot that first point. And then, remember we knew it was a V shape, so then you just draw your V in from there. Again, doing the same over 1, up 1, and being accurate as you draw that in. Remember, I want to clearly see at least those points that are the furthest away from your vertex. Once you've drawn those in, You use your ruler, you use your straight edge, connect the dots, and you put all the pieces together. Now, I really like starting with the absolute value graph because we can see that vertex nice and clearly when we plot this, but it's fairly easy to remember this pattern of over 1, up 1 all the way along. We get to use a straight edge, makes life a little easier. But a similar one, but different in its shape and pattern, is the quadratic. And so we're also going to take a look at the quadratic today and plot the points, the individual points for that. So above your next graphic grid, please write this equation. Y equals x squared. So I put the first point here at 0, 0. And then it's a question of where do we go from there. And I can tell you it's not going to be over 1, up 1 all the way along. That would not give us a U shape. So we do have to see what is it going to do all the way along. Well, let's see what happens if I go over 1. If I go over 1, I end up actually going up 1 again. Go ahead and plot that point. The reason is this is x squared. My x is how far I go over. So I'm doing then 1 squared. 1 squared is 1, because 1 squared means 1 times 1. So that's why we go over 1 and up 1. Okay, let's go over 2 next. Give you a hint, we'll not go up 2. It's over 2 and up. Well, let's calculate it out. Again, y equals x squared. What's 2 squared? In other words, 2 times 2 is 4. And so if I go over 2 then, I need to then go, oops, that's a little bit too far. If I go over 2, I go up 4 to get to that next point. So plot that point now, over 2 and up 4. We can use the same reasoning and get to our next point. If I go over 3, I'm going to be doing 3 squared. Remember, 3 squared means 3 times 3. So what does 3 squared equals? 9. Yeah. So that means that from my first point, notice I'm always counting from that first point that I plotted, not the last point. I'm going to go over 3 and I'm going to go up 9. So go ahead and plot that one. Now I just did the stuff on the right side. On the left side, it's going to do the exact same thing because anytime you square a negative, it gives you another positive. And we could get into lots of details on that, but I'm more interested in you having this pattern down first, and we can get into the mathematical details as we go on. Make sure each of those points is neatly and clearly plotted on your paper. We're talking big dots that don't disappear as soon as you draw the curve over them. Because these are the dots that you are going to come back to and use as a reference as we go forward. Because I don't expect you to have this pattern totally memorized today. It's going to take a few days to get comfortable with it and to get natural with it. When you draw the curve that goes through those points, this is what it should be looking like. This is the exact curve. It's going to take you a little bit of time to get to know that as well and to train your hand to draw it nicely. Find the ways that work best for you. There's lots of different tricks that you can use to make that curve come out looking nice. One of them is that you can start by kind of drawing the little U part down here, because that can help make sure that that stays curved. For me, the thing that I always have to do, I always have to turn my paper sideways in order for the curve to come out looking, well, like a 5-year-old didn't draw it. So you find the thing that's most natural for you that helps you to draw that curve in. And when you do, then all of a sudden you can graph all sorts of these quadratics. So let's take on a number of them. Please write down this equation above your next graphing grid. Y equals x minus 3 squared. So this is another one of those graphs where we're moving it. Now, when we did our absolute value, we looked to see, is the number in with x? You notice we can actually ask that same question here. Is the number in the parentheses with the x? Is it here? Yeah. This minus 3 is in with x, which already tells us that this is going to be going in the x direction. So then minus moves it which direction? Yep, it moves it to the right by 3. Just like it did with absolute value. And in fact, just like it's going to do with every single function type you see this year. If you see a minus 3 in with x, it goes right, not left. Once you plotted that point, that first point, that vertex, you can now draw on the rest of your graph. If I go over 1 from there, how far up should I go? 1. We can see that in the previous example. If I go over 2, how far up should I go? And you can look back at your last graph that you made and see, okay, count over 2, how far up did I go? I can count up 4. And when we counted over 3, how far up are we going to go? 9. Because remember, 3 squared is 9. You can count that out from your example graph that you have from the last problem. That's our parent function. Once you know what the parent function points are, you know what all of these other points are as well. And so you plot those points nice and neat. Now notice with this one, I'm not telling you some bare minimum number of points. This is not one of those where you can just plot the vertex and the ones that are on the outside. It's not going to work right if you do that. You actually have to plot each of the points along the way. Thankfully, there's not that many of them. With absolute value, I give you that shortcut just because sometimes there can be a ton of them. But here there's not all that many of them. So yes, we want to plot them each, and then it's going to help us to get that curve nice and smooth and looking good, like that. Okay. Let's do 2 more examples. Above your next graphing grid, please write this equation. We got y equals x squared minus 2. First up, what's the shape of this graph going to be? Yep, it's going to be the U shape. How do I know? Because it's got a squared in it. Anytime you see that squared, that x squared somewhere in your equation, you know it's going to be the U-shaped graph. The question here is, what does the minus 2 do? Okay? Is the minus 2 in with x? No. It's hanging on the end. That tells me that it's going to be going up or down. The question then is, minus 2, does that go up or does it go down? It does go down, yeah. So this graph goes down 2. So first thing you do, plot your point, down 2. And once you've done that, you repeat your parent function the same way as you did before. You go over 1 and up, 1. Then you go over 2 and up how far? 4, yep. And you go over 3 and up 9. Now, a little thing to look out for here. Make sure that you're counting up 9. You're counting up 9 from the first point. You're not going back up to 9. You're counting up 9 from the first point that you plotted. That can be an easy mistake to make, especially at first. So make sure you're actually doing that counting to get that 9 point at the right height. Oops, I have that one over 1 too far. There we go. That's looking good. And then once you have each of those points, yes, each of them plotted, then go ahead and draw your curve that goes through them. Then one last one to do here. Please write this equation above your next graphing grid. Y equals x plus 1 squared plus 3. All right, so first thing, what's the shape of this graph going to be? Yep, it's going to be that U shape. I know that because I see squared is in the equation. So that gives me the U shape. Now that I know it's a U shape, I just need to know where to start from. Okay, the plus 1. Which way does the plus 1 move it? Up, down, left, or right? Yep, it goes left. I know first of all that it's sideways because it's in with the x. And then once I know that, plus goes left, minus goes right. And so I'm going to go left 1. And then the 3, the plus 3, that's hanging on the end, so that's either up or down. Does plus 3 move it up or does it move it down? Yep, it moves it up. And so I'm going to be going up 3. So that's where your first point goes. Go left 1, up 3, and plot that point. Having done that, we can now go ahead and fill in the rest of the graph. So when I go to plot my points here, I go over 1 and up 1, I go over 2 and I go up 4, but what about the over 3? Because you notice when I go over 3, I'm trying to go up 9, but up 9 is like up here somewhere. It's off the graphing grid. When that happens, just means you don't need to worry about plotting that one point.